Okay, let's unpack this deep dive. We are talking about concrete floors in Central Florida, specifically in Lakeland and Polk County. Now, a concrete floor coating like on your garage sounds simple, right?
You'd think so. A weekend project, maybe.
Exactly. But that seeming simplicity is a paradox. Building a simple, durable concrete floor here is one of the most complex construction challenges in the country.
It truly is. And this deep dive is necessary because the incredible pace of growth in Central Florida is just constantly running up against these incredibly unforgiving environmental conditions.
And regulations, too.
And regulations, yes. So our mission today is to synthesize a stack of sources. We've got the 2026 Florida Economic Outlook, some specialized engineering reports for Lakeland, and the state contractor licensing rules.
Our mission is essentially to build the ultimate bulletproof floor. And it seems like that requires 3 layers of protection: geology, chemistry, and then, financial protection.
That's the framework. And you, the listener, you really need to understand all three to make sure your investment lasts.
So where do we start?
We have to start at the foundation, literally. The ground beneath Lakeland dictates everything else.
Let's talk about that because it sounds almost terrifying. Before we even talk about a single chemical, we have to acknowledge that Polk County is right in the middle of Sinkhole Alley.
It's the single biggest hurdle. It's what's known as karst topography.
Okay, break that down.
Picture the limestone bedrock under your property. Now imagine acidic groundwater has spent millennia dissolving it, basically turning that solid rock into something like Swiss cheese.
Wow.
It's a massive sponge full of voids and channels. So the stability of your concrete slab is never, ever a given. It's a permanent battle.
So the foundation itself is potentially unstable. What about the soil it's sitting on?
Well, the soil is overwhelmingly sandy, and sand has incredibly high permeability.
Meaning water just rushes right through it.
Instantly. So during those intense summer rains we get, that sandy subgrade can just wash out, eroding right into those limestone voids underneath.
And that leads to the floor inside your house settling unevenly.
Directly. That's where you get the cracks, the movement, and eventually the failure of any coating you put on top, no matter how good it is.
Which is why we're seeing things like GPR ground-penetrating radar becoming more common for these jobs, right?
Exactly. GPR is like an X-ray for the ground. It maps out those voids. And if there's already instability, professionals have to use things like polyurethane injection.
Where they pump foam under the slab?
Basically, yeah. A specialized foam to fill the voids and stabilize the base before you even think about putting a finish on top.
So we've fought the earth itself, but now there's water coming up through the earth, the invisible threat. Moisture vapor?
It's the second and just as destructive force. The water table in Central Florida is notoriously shallow.
How shallow?
In some parts of Lakeland, it's estimated to be less than a foot below the ground, and concrete is porous, so it acts like a giant damp sponge.
It's constantly breathing this water vapor. So if you put a standard non-breathable coating, like a cheap epoxy, on top of that,
You've just created a pressure cooker. It's a catastrophic failure waiting to happen. That trapped vapor creates immense hydrostatic pressure.
so much pressure that it can just push the coating off.
It can literally exceed the physical bond strength of the resin. You get these huge bubbles. That's called osmotic blistering. And then the whole coating just delaminates. It peels right off.
Which is why moisture testing is absolutely mandatory here. What's the standard for that now?
The 2026 gold standard isn't a surface test. It's in situ relative humidity probes. That's the ASTM F2170 test.
So you're drilling into the concrete.
Tiny holes, yes. You insert probes and measure the RH inside the slab itself. Most high-performance systems require a reading below 80% relative humidity.
And if it's higher?
Then you have to use a specialized moisture-mitigating primer. This isn't just a regular primer. It's a chemical barrier engineered to withstand intense pressure, sometimes up to 25 psi.
Give me some context. What is 25 psi like?
25 psi is like stacking about 3,600 pounds on every single square foot of your floor. It's an incredible amount of upward force.
That's amazing. So beyond the ground and the moisture, Florida hits you with a third strike, the climate above ground.
Absolutely. The coatings face relentless UV radiation, especially on the apron of the garage where the sun just bakes it all day.
Which leads to yellowing and breakdown.
Photooxidative degradation, yes. It gets yellow, chalky, and falls apart.
And the temperature swings must be brutal.
They're relentless. A concrete slab can go from 40 degrees on a winter morning to 140 degrees in the summer sun. A standard rigid epoxy just can't flex with that 100-degree swing. It cracks.
Okay, that paints the full picture of the stress test. So let's pivot. Section 2, the technical solution. If standard epoxy is just doomed to fail, what chemistry actually works.
The rigid epoxy is fundamentally the wrong choice. It's cheap, but it's a short-term fix. The premium solution, the professional standard, is using aliphatic polyaspartic top coats.
Okay, why is that combination aliphatic polyaspartic the key?
Two big reasons. First, aliphatic coatings are engineered to be 100% UV stable. They just will not yellow in the sun. Second, polyurea and polyaspartic polymers are just. They're much more flexible than epoxy.
How much more?
Up to 4 times more flexible. So the coating moves perfectly with the concrete as it expands and contracts. No stress cracks.
So what's the real-world difference in lifespan?
The performance gap is huge. Standard epoxy, you might get 5 to 10 years, maybe less with moisture issues. A polyaspartic system, you're looking at a 20 to 25-year lifespan.
Okay, but here's the thing. The best material in the world will still fail if the prep work is bad. And I hear that in Lakeland, failure is usually about bad prep.
That is spot on. Preparation is everything. The professional standard absolutely mandates mechanical diamond grinding.
And this isn't just like sanding the floor.
Not at all. This is heavy machinery with diamond blades to get a specific texture. It's called a concrete surface profile, or CSP, of 3 or 4.
And what's the point of grinding it so aggressively?
Two things. First, you're removing the latents, that weak, chalky top layer of the concrete. You have to get down to the strong, virgin concrete underneath.
I see.
Second, that rough profile creates a deep mechanical tooth. The resin flows into that texture and creates a physical bond, not just a chemical one.
The sources were really, really harsh on DIY methods like acid etching.
For very good reason.
Yeah.
Acid etching floods the concrete with water, which is the last thing you want here. Plus, it just doesn't create the aggressive profile you need for these industrial-grade systems to really grab onto.
Okay, so let's talk cost. We know the polyaspartic system is better, but how much more are we talking, and how do you justify that to a homeowner?
That is the critical question. Professional installs can range from $3 to $12 a square foot. For these high-quality residential flake systems, you're often starting around that $8 to $13 range.
So let's break that down. Epoxy might be, say, $3 to $7. The polyaspartic system is $8 to $15. That's a big jump up front.
It is a high initial cost, but you have to look at the total cost of ownership. The polyaspartic lasts 20, 25 years. The epoxy, in this climate, you'll be lucky to get 5 to 10 before you have to pay someone to grind it all off and start over.
So you're buying a floor that lasts 2 or 3 times as long.
Exactly. You're eliminating multiple replacement costs down the road. The more expensive material is, without a doubt, the better long-term investment.
And building codes are starting to catch up with the reality of modern homes and cars, right?
Absolutely. The 2023 Florida Building Code mandates that garage surfaces have to support concentrated live loads up to 3,000 pounds. Think about a big SUV or an EV with a heavy battery pack.
Right. And drainage.
Also crucial. The code requires a minimum slope of 1/4 inch per foot to make sure water drains out properly and doesn't pool inside.
All right, we've covered the ground, the water, the materials. Let's move to that final layer, the contractor and the financial landscape you're dealing with in 2026.
Okay, so the big picture is that the Florida economy is expected to moderate a bit in 2026. But construction is still a huge driver. But, and it's a big but, the sector is facing some serious headwinds.
And those headwinds hit the homeowner's wallet.
They do.
Oh.
Home repair and remodeling costs rose 3.4% year over year in Q2 2025. That's mostly driven by labor. Construction wages are just rising faster than everything else.
And I assume materials are still volatile.
Very. Tariffs are a huge factor. You've got a 35% tariff on Canadian lumber, 25% on Mexican gypsum. Now, that's not flooring material, but it drives up the total project cost, which puts pressure on contractors to cut corners somewhere else.
And that somewhere else could be your floor prep or materials.
It often is.
Which means vetting your contractor is more important than ever.
Let's talk about licenses in Florida. There's certified versus registered. Why does that matter?
It matters for accountability. A certified license is valid statewide. It means they've passed a tough state exam and shown 4 years of experience. They've proven their expertise at a high level.
And a registered license is limited to a specific local area, like Polk County. It requires a local certificate, but it's not the same rigorous state-level exam. It might signal a different level of experience or financial stability.
What about permits? In Lakeland, if I'm just getting my garage floor coated, do I need a permit?
For simple coating, usually no. But And this is critical, if the job involves any kind of foundation remediation or structural repair, like that polyurethane injection we talked about.
Which is common in Polk County.
Very common. Then a permit is absolutely required. If a contractor says they don't need a permit for soil stabilization, that is a massive red flag.
And then there's insurance. What are the minimums a homeowner should be looking for?
For specialty contractors, which covers most flooring companies, they need to have at least $100,000 in liability and $25,000 in property damage, plus workers' comp if they have employees.
But what if things go really wrong? Say they abandon the job or cause major damage. Is there a safety net?
Yes, and this is so important for consumers to know about. It's the Florida Homeowners Construction Recovery Fund. It's specifically for when a contractor causes financial harm through things like abandonment or mismanagement.
What's the most you can get from that fund?
For contracts signed on or after July 1st, 2024, the cap for claims against specialty contractors is $30,000. For general contractors, it's higher at $100,000. You need to know those limits.
Okay, last piece of this puzzle. Lifetime warranties. They sound great, but the fine print must be full of exclusions.
Oh, absolutely. You have to be ruthless reading that fine print, especially here. Most warranties will have a blanket exclusion for failure from moisture vapor transmission.
MVT.
Right, unless the contractor did that certified ASTM testing and installed the proper moisture barrier.
So if they skip the test and the floor fails from moisture 5 years later, you're out of luck.
You're out of luck. The warranty is void. They also routinely exclude damage from the substrate cracking, due to soil movement.
Because that's a foundation problem, not a coating problem.
Exactly. And that last one is the garage apron, the part that gets all the sun. Many warranties exclude yellowing or fading there, even with a polyaspartic top coat. You have to check.
This has been a true deep dive. It's an entire ecosystem of geology, chemistry, and finance, all for what seems like a simple floor. Let's wrap it up with the core takeaways.
Okay, 3 layers of defense. That's what you need. First, geological and moisture mitigation. Demand that slab analysis, insist on the MVT testing, and get the moisture barrier if you need it. Second, demand climate-adapted chemistry. That means flexible, UV-stable polyaspartic. And third, verify your contractor. Make sure they have the right license, preferably certified the right insurance, and that they understand local permitting. If you skip any one of those, your risk of a costly failure goes way, way up.
We saw in the economic outlook that construction firms have been sacrificing their profit margins to keep prices stable. But that can't last. The challenge for 2026 is for them to stay profitable by being, and I'm quoting here, ruthless in cost control and bidding correctly. And this raises a big question for you, the consumer, that you'll see in the quotes you get. As this market pressure continues, will contractors push for the long-term value of robust, climate-specific solutions like polyaspartic? Or will the pressure to win bids force them back to cheaper, lower-quality materials like standard epoxy that are just going to fail sooner in this brutal Florida environment? It's a tension between upfront cost and long-term durability, and that really defines this entire challenge in Central Florida right now.